Now the reaction between an acid and a base will always result in a salt plus H2O or water in a liquid phase. For instance, we have HCl with strong base NaOH. We will result in NaCl plus H2O. We write this down. Aqueous, aqueous. The salt will also be dissolved in water, and therefore we also write down the phase as aqueous phase. This we call a molecular reaction because we write down all the involved molecules in the reactions, whether they are reactants or they are products. Now actually, because strong acid, strong base, and salt, all of them dissociate completely in water, we can also write down what actually happens in the system, which is that HCl dissociates into H plus Cl minus, and NaOH dissociates into Na plus OH minus, and NaCl dissociates into Na plus Cl minus, while the H2O, because it's water, a covalently bonded molecule in liquid form, will not dissociate. So H2O stays as H2O. Okay? Now this one you call the total ionic reaction. You may notice that you actually have some of the ions on both sides. For instance, Cl, you have it here, you also have it there. You have sodium here, also sodium there. These types of ions, we call them the spectator ion. Spectator ions. Because they are on both sides. So you can actually cancel them out. Cancel them out, Cl and Cl, sodium plus and sodium plus. And therefore, you will get another reaction, which is H plus OH minus becoming H2O liquid. When you have removed these spectator ions, you will get a net ionic reaction. So you can have three types of reactions: the molecular one, the total ionic one, or the net ionic one for the acid-base reaction. Now let's take another example, but this time let's use a weak acid plus a strong base. Now, weak acid, unlike strong acid like this, it will not dissociate completely. Therefore, we don't write the ions because mostly the dominant species will still be the unionized form like this. So let's write weak acid just as it is. While the base, because NaOH is a strong base, then we have to dissociate them because it dissociates completely in water. Okay? What about this? This is a salt. How do we know that this is a salt? Because it comprises of a cation, which is sodium plus, and an anion, which is CH3COO minus, or the acetate ion. Therefore, because this is a salt, it will also dissociate completely in water. So we also have to write them in the dissociated conditions. H2O, as usual, stays as H2O. This is the molecular reaction above, The bottom is the total ionic equation or total ionic reaction. And now you can see the spectator ion this time becomes only the sodium. That's the only ion that is present in both sides, so we can cancel them out. And we will have our net ionic reaction like this. Aqueous CH3COO minus aqueous plus H2O liquid. So now this is what our net ionic reaction looks like. Pay attention to the difference with the one that we got from a reaction of a strong acid, strong base. Now, this is what it looks like if we have instead a weak acid plus strong base. Now, please try on your own to find other variations of acid-base reaction using examples that are on these tables. I mentioned before that salts are strong electrolytes, just like strong acid and strong bases. However, there are some salts, several examples of salts are insoluble in water, meaning that they form precipitant or they precipitate in water. Now these types of salt we will write down not in aqueous phase but instead in solid phase because it is not dissolved in water because it is insoluble. So instead we will write down in solid phase because we can see them in experiments coming out of the solution forming precipitants or solid form. Here you are looking at the list from our textbook for salts that are usually soluble and salts that are usually insoluble. Please memorize the list in the table. Okay? Especially the insoluble one. For instance, all of the salts that contain phosphate, carbonate, hydroxide, and sulfide as their anions tend to be insoluble, except for these written salts over here. Please try to remember them because it's very handy for you to be able to write down the reaction. Say you have two soluble salts. You have potassium carbonate and calcium chloride. You know that they are soluble based again on this table, yeah? Potassium chloride and all of chlorides, bromides, iodides, salts, they are usually soluble. So you can write down this in aqueous phase, this also in aqueous phase. Now they react, they will exchange their partners. So this will result in KCl, all right, plus CaCO3. Now, KCl is still soluble because all Cl minus, all salts that contain Cl minus are usually soluble. So you can still write this down as aqueous. However, calcium carbonate, you can see in here, carbonates are usually insoluble except for ammonium carbonate, sodium carbonate, and potassium carbonate. Of course, then calcium carbonate is not an exception, so it is insoluble. So instead, you write this down in solid form because it is an insoluble salt. Here you have a molecular reaction. Let's write down the total ionic reaction and the net ionic reaction. All of salts that are soluble dissociate completely. So you get but first, before we write it down, check whether this reaction is already balanced. Take a moment to balance this reaction. If you did it correctly, you will get this reaction as written here. And now we can write down the ions, which is 2K plus, CO3 2 minus, plus Ca2 plus aqueous, plus 2Cl minus. Don't forget, all soluble salts dissociate completely. And in this case, 2K plus 2Cl minus. While the calcium carbonate, because it's solid, of course it will not dissociate. Just like the weak acid or weak base. Okay? So now you can cancel out the spectator ions, which are K plus, yeah, and Cl minus. Alright? So now you are left with the net ionic equation, which is this one. So the net ionic equation for this reaction is the reaction between calcium ion with carbonate anion to form a precipitant of calcium carbonate. This is what we call the precipitation reaction. Now, what if we have this reaction? Yeah, if we try first just to exchange the partners, we will get sodium nitrate and ammonium chloride. Yeah, that's ammonium plus chloride. Now, all of nitrate salt and all of chloride salts, they are soluble. How do we know this? Go back to this powerful table. Yeah, all nitrates or all chlorides, they are usually soluble. So everything should be in aqueous, 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 aqueous. So if you write down the reaction, everything is going to dissociate because they are all water soluble. Get this, plus that one, plus that one, plus that one. And now you can see that each part of these reactions now, they are all spectator ions, right? So in this case, we say that there is no reaction occurs for the system because we cannot find the net ionic reaction, as all of the ions, whether cations or anions, they are all spectator ions. Okay? You can see the difference clearly for these type of reactions with these types of reactions.